ladies and gentlemen. It's my great pleasure to welcome you to what turns out, I think, to be the 5th year of these Data Science Festival main stage events. I've been to each of them. The quality of the talks was brilliant to start with, and it's only got better over the years. Just while we get the last few people in, just a few bits of admin. There are no fire alarms scheduled for today, so if the alarms do go off, please leave quickly and quietly. Fire exits are behind you in the entranceway where you came in. There's water by the door if you find the coughing fit starting to break out. Please put your phones onto silent to avoid disturbing the speakers and your compatriots. You've got a schedule for the day's talks in your bag. We'll try and keep to time so that you don't miss the talks you want to see. If you've got any questions about the event, there are lots of data science volunteers in the black T-shirts around. Please do ask them what you need to know. This is very much a community event. You know, the speakers give their time for free, and people come along and engage with the speakers every year, which is great to see. But we couldn't do this without our sponsors. This year they include Attest, Barclays, Bumble, CFC, Data Idols, Databricks, Deliveroo, Digitas, King, H2O.ai, DirectLine, dunnhumby, Marks & Spencer's, OpenCredo, and finally CodeNode, who've provided a great environment to have our talks in today. We're going to do Q&A after this session, but not after the following session. I won't be handing the microphone round, so if you just like to ask your question out loud, nice and clearly, and I will repeat it for the benefit of the remainder of the audience. So, time to get on to our first talk of the 2022 Data Science Festival main stage. And that's from Rebecca Vickery, who's the EDF Data Science lead. She's going to be talking about identifying financial vulnerability with unsupervised machine learning. Rebecca's the lead on developing the data science-based products that EDF uses to help their customers. And she's also passionate about diversity in data science. She's just started an internal network at EDF to bring together the women working in the data science and technology sectors there. So without more ado, over to Rebecca.
Thank you very much for that introduction, and good morning everyone. It's really, really great to be speaking at the Data Science Festival today, and thank you for coming to this session, because I know there are loads of other sessions on at the same time that are really good, so thank you for joining this one. So I'm going to be talking about a project that our data science team have been working on over the last few months. It is a project around identifying financial vulnerability with unsupervised machine learning. I'm going to talk about some of the technical aspects of the project, but the main part of my talk will be about 5 guiding principles that we've used at EDF across the data science team on numerous projects to ensure that their success, and I'm going to talk about how we've applied those to this particular project as well. So before I get on to the actual project, I'm going to give a little bit of background to me, who I am, EDF, who we are, and also I'll talk about the data science team and how we work. So as you probably heard in the introduction, I'm the data science lead at EDF. I work across the data science product teams, so I'll talk a little bit more about those in a minute, ensuring kind of the technical work across all of those teams, kind of acting like the technical lead. I've worked in data science for just over 5 years, and in data in general, in a variety of roles before I got to data science, for over 15 years. I also, in my spare time, really like to write about data science, so you can also find me on Medium if you're interested. So who are EDF? So we are one of the UK's largest energy companies. We're also Britain's biggest generator of zero carbon electricity. We have 2 sides to the business, so we both generate electricity and we also supply energy. So we have the generation side of the business. We also have the customers business, which is more focused on the supply. But across the whole of EDF, we are all focused on one very powerful mission, and that's to help Britain achieve net zero. So what that all means is that we've got some really, really large, varied data sets, and we've got a very powerful, impactful mission across the whole of the data science team, which makes it a really exciting place to be a data scientist. So next I'm going to talk a little bit about our data science team and how we work. But before I get onto that, I'm going to talk about our wider kind of function that data science is a part of, and that's called the Data and CRM team. So that forms our data centre of excellence. And this slide just shows kind of some of the roles that are in there. And one of the important things, I guess, to take from this is that I'm sure you probably all heard the phrase data science is a team sport. And I think that's very, very true. So as a data science team, we can't do everything we want to do without support from other roles. So the great thing about being part of this wider data and CRM team is that we can work collaboratively with all the other roles in this space to kind of really help to make our products a success. So data science at EDF, how do we work? So we do work in a very agile way. We organise ourselves into product teams, or squads, as we sometimes call them. So the product teams are usually kept relatively small in size. They can consist of whatever roles are needed to make that particular product that we're working on a success. So that might mean just a team of data scientists, or it might mean a team of data scientists, data engineers, DevOps engineers, or indeed any other role that is important for that product. At the helm of every product team, we have a product lead as well, who also helps ensure the success of that product by kind of setting our roadmaps, making sure we all understand what we're trying to achieve, removing blockers for us, that sort of thing. And then as the data science lead, I work across all of those product teams, ensuring kind of the technical leadership effectively across them. But as we work in these individual product teams as data scientists, what we want to ensure is that our working practices, the best practices we implement, the ways of working are consistent across them, and also knowledge sharing is really important. So in order to ensure that, we also have the concept of a chapter for the data science team. So what that is basically an opportunity for us to kind of get together as a team, work on combined capability building effectively for our team as well. So we do things like we meet weekly, we have a session where we share what we've been working on, share interesting new tools, ways of working that we've come up with. Additionally, at EDF, we also have guilds. So we have guilds for different different fields. So software engineering, we have a guild for that. Data engineering, we have a guild for that. And also data science, we have a guild. The guilds are quite wider than chapters. So the guilds are really for anyone who's got an interest in data science, would like to be a data scientist, or indeed is a data scientist. So it's really just a great data science community. Okay, so hopefully that's given you a little bit of background into EDF and data science and how we work. I'm going to now move on to talking about the actual project itself. But as I said at the start, I want to kind of do this around the typical project principles that we apply to most of our data science projects that help to ensure success. And these are listed out on this slide. And what I'll do in the rest of this talk is just kind of talk in detail around each of these, and I'll talk about how we've applied these to the project that I'm talking about. So the first one is all about tackling problems with clear actions. So with our data science products, our measure of success is that our data science products that we are creating are both useful and are used somewhere. So that's really important to us. And one of the best ways of ensuring that actually happens is that the problem that we're tackling, not only is it a clear, defined problem, but it also has very clear actions that the stakeholders can take. And that really, really helps, we've experienced, to make the product a success. So in terms of the project that I'm talking about today, what's the problem there? So to give a little bit of background into the problem, I'm going to talk about something which I'm sure everyone in the room has heard about, is probably feeling the impact of, and that is the energy price rises that we're all experiencing right now. So as over the last few months, the energy prices have risen in an unprecedented way. In April, we saw the energy price cap, and that's the maximum amount that the government allow energy providers to charge for their kind of standard variable tariffs, rose by 54%. So that's a huge, huge increase. And we know that that's impacting all of our customers, and in particular is impacting some of our most vulnerable customers. And on this slide, there's just a few stats around, what we're hearing from, charities, organisations that we work from about the impact of that. So that's kind of the background for the problem. So we know already in EDF we have financially vulnerable customers. We know we do, and we already have a whole range of support that we provide to these customers. On this slide, this is just a few examples of things that we already do. So we work with other partners, so charities like Citizens Advice, Income Max, that helps people to ensure that if they're on benefits, that they're getting the maximum benefits that they are entitled to. We have a customer support fund which provides financial support to customers. We also provide tailored support to our pay-as-you-go customers. And I'll get onto the pay-as-you-go customers in a bit more detail in a second, because that's quite integral to the project that I'm talking about today. But we do things like helping them with pausing debt repayments and also providing sort of temporary credit and that kind of thing. So that was our problem. So our problem is we want to identify our financially vulnerable customers so that we can reach out and help them. We do have an existing solution for this, and that is something called the Priority Services Register, which is also sometimes shortened as PSR. So I might use PSR when I talk about this in the talk. But out of interest, actually, I wanted to ask the audience for just a show of hands, if anyone's previously heard of the PSR, or Priority Services Register. Could you raise your hand, please? Yes, so very, very small number of people. Okay, so that illustrates nicely my point, which is that for many reasons, and one of them is that people might not be aware of it, people who are financially vulnerable may not be on our Priority Services Register, so we might not know about them, and we might not be able to reach out to them to give them this help that we have. So we have an existing solution, but it is imperfect. And so for data science, we saw this as an opportunity to help. Okay, so that's the problem. The next principle is about stakeholder in the loop development. So this is about the really importance of having engaged stakeholders involved in the development all the way through, from the beginning of the project and all stages of the project. Now for us, what we've identified is largely, and this isn't across everything, but largely there are two types of stakeholders that we need to have involved in the project, and they are very different. They play a very different role in what they do in the project. So on the one hand, we have our sponsors. So our sponsors are generally senior level stakeholders who basically sponsor the project. So they, what we need from them is we need buy-in. So we need them to support the project. So they will give us the resource that we need and the time that we need to work on it. What we also need, though, is we need our domain experts. So our domain experts are more the people on the ground who are taking the actions that our model hopefully will drive. And the domain experts, we work really closely with them. So as the senior stakeholders, sponsors, we might meet with them, let's say every 2 weeks, just give them an update on the project, make sure they're engaged, make sure we've got that buy-in. The domain experts actually really help us and get involved in the project. And actually the senior stakeholders, the sponsors, quite often ensure that. So they're the ones that, ensure that the domain experts have got the time to help us. And in this particular project, because it's unsupervised learning, and I'll talk a little bit more about why this is particularly important, but we found they were particularly important for unsupervised machine learning. So one example of where the domain experts really helped us was around the concept of self-disconnection. So this really helped us to kind of get started with the project and understand where we should go first. So self-disconnection is related to people who pay for their energy on pay-as-you-go meters. Pay-as-you-go meters are where you basically put credit onto your meter, so you pay upfront for the energy that you use. Self-disconnection is when the consumer stops topping up their meter, so they go without energy for periods of time. And unsurprisingly, this has been linked strongly to fuel poverty. And the domain experts were the people who gave us this information and also gave us information about where we might find the data to find this, and that this would be a really good starting point. So once we got our stakeholders involved, the next project principle for us is about starting simply. So we don't go for the most complex solution straight away. We start with something really simple. So in the spirit of starting simply, we started with the data that we had readily available with some information from our domain experts. And that happened to be data that was generated from the smart pay-as-you-go meters. So some of those features that were on the previous slide around sort of how much are they topping up, how frequently are they topping up, and are they stopping topping up for periods of time. We also did some experimentation as well to find the features, because when initially we identified some features with our stakeholders, and then we kind of reduced that down to a smaller amount of features from experimentation. So we started simply with the data. We also started simply with a very simple solution so that we could get something into use as soon as possible and then get the feedback to understand if our solution is really improving things. So the solution that we had, we didn't have a label for our data. We didn't have a good enough ground truth. We had the PSR flag, but as I've already talked about, that is an imperfect data point, effectively. So we didn't have a good ground truth. So for us, the only option really was something unsupervised. And so what we went for in our first simple solution was a simple clustering algorithm. We actually used, incidentally, k-means in the end after some experimentation. We also found, with experimentation, that despite trying lots of features, that actually 3 features gave us a good enough clustering, which had the added benefit that that was highly interpretable, which really helped us because, and I'll come on to this a little bit later, but building trust with the stakeholders to use our model was also really, really important in this project. So we had our model, and what we also found was that unsupervised machine learning presents its own set of challenges when you're trying to use it in the real world. So one of those is around validation. So with a supervised machine learning algorithm, you have a standard set of metrics, and you have a label as well, that enable you to kind of validate if it's learning something useful. So, if it's a classifier, you have precision and recall and so on. With unsupervised machine learning, you do have, obviously, some metrics that will tell you how well separated the clusters are, what's the cohesion of those clusters. You do have those metrics, and we did use those. But they weren't really enough for this, and the reason they weren't enough was for 2 reasons. One was that we weren't just interested in the inherent clusteringness of the data. We were interested in targeting specific segments. We wanted to find financially vulnerable customers, so we needed to understand if one of the clusters was identifying that. We also, the other thing is that the stakeholders, the team that we were working with in this problem, they hadn't used machine learning before. So they had been using the PSR flag as their sort of indicator. So to get them to move to a new solution that was data science-led, machine learning-led, was a bit of a challenge, and we really needed to build that trust. So we needed to be able to validate it in a way that the stakeholders could really understand. And those metrics that I've talked about, like the silhouette score and so on, just didn't cut it, basically. So that's when I come on to the next principle, which is stakeholder in the loop validation, which is a really important aspect of getting your stakeholders involved in the validation process. So, as I said before, we did additional validation. So we used 3 different types of validation on top of the regular kind of metrics that you might use for clustering. We used an existing indicator. We used some exploratory data analysis, and I'll talk through that in a bit more detail. And we got the domain experts involved. So the first type of validation we used was the PSR indicator. So although it's an imperfect indicator, we know that it's an indicator of the financially vulnerable customers that we do know about. So one of the validation that we did was to look at what's the prevalence for each of the clusters for the PSR flag, essentially. And the PSR flag, as a general thing, the PSR flag just identifies general vulnerability, but within that there are categorizations. So for this particular piece of validation, we use something called the FinV flag, which is, it specifically identifies financially vulnerable customers. So this is what we found. This is the results. So we had, as I said before, we had 3 clusters. We had a cluster that looked like it was financially vulnerable customers. We had one cluster that looked like it was very secure customers. We had a third cluster, so I've sort of talked about that earlier on, but we had a third cluster. So the third cluster, those people don't fit into really either of these segments. So for now, that's unlabeled. So we've left that unlabeled because we're taking an iterative approach on this project. So probably the next iteration is going to be, let's try and understand this group a bit better. But as you can see, the general populations, we've got the full population there. That's got a prevalence of about 14.6% is the proportion. There, the financially vulnerable customers we can see is higher. And then the other, which is reassuring, it was reassuring to us, very reassuring to the stakeholders. And we can also see that the secure cluster is much lower. So again, it was reassuring. But not enough, because it is an imperfect indicator. So what we also did was some exploratory analysis. So we did a couple of different types of exploratory analysis. We did some high-level analysis, and that was around things like just looking at those features that we had used for the model. We were looking at things like the distributions, and using our sort of own intuition as to what we expected those distributions and other parts of analysis to look like, and did it meet our expectations. The other thing that was very, very useful to us, in particular when we were talking to the stakeholders, was to just take a sample of customers from each of the clusters and to look at a very detailed level as to what their behaviour is. So on this slide, you'll see that we have these are two individual customers from each of the clusters. We've got the vulnerable cluster here, and what you can see here is that we're seeing on here, we're seeing the top-up amount, how much are they topping up over time, and then we've also got a thing here which tells us if they've had a disconnection, so the self-disconnections I talked about earlier. And what we can see from the vulnerable cluster is that people are topping up very different amounts, very varied amounts over time, and they obviously have got these disconnections. And then on the right-hand side of the screen over here, what we can see is this is from the secure cluster. And the secure cluster, you can see from here, they're topping up consistently £50 every time, and they have no disconnections. So that was very reassuring. So what we also did, of course, was got the stakeholders involved, because we had our own intuition as data scientists, but we don't have the same domain knowledge as the domain experts. So we really needed to get those people involved and understand if they agree with us. So what we did was we used those visualizations, and as I said before, the particularly useful ones were those granular customer level visualizations, and we just talked them through on a regular basis with the stakeholders to get them to kind of understand and also tell us if they thought that the model was doing something useful. So that's brings us to the fifth project principle. So the fifth one is deploy, then iterate. So I've talked about the importance of starting simply with something. And I think the other aspect of that is to get that simple solution into production and in front of the stakeholder, so the stakeholder can start to use it, and obviously has the benefit that we can start to get that feedback, because you never know, no matter how good your model actually is, if it's going to perform well once it's actually used in a real world use case. So I'm going to touch on the deployment just kind of briefly. So and I won't go into this in too much detail, but we were already starting to think about building a unified platform for deployment of models. So we were deploying models, but we were doing them in a disparate way. So what we also wanted to do was build out a platform that was kind of a bit more unified for deployment. And what we decided to do was actually use this particular model as an example use case to build out this platform as well. Now, as I've said before, we do work in a very agile fashion, so we did want to just try and build, the all singing, all dancing platform. We wanted to start with an MVP, a minimum viable product, to begin with. So we kind of identified for this use case what are the minimum requirements that we need actually just for this use case. Now, for this particular model, we don't need to serve this, so we don't need to do kind of like, real-time inference. We don't need to serve it as an API or something. We actually need to do what we call batch deployment. So batch deployment is just everything happens offline. So all we're doing is taking some data, generating some predictions, and then putting that data somewhere. For us, that was Tableau, where our stakeholders could get hold of it. So we walked through kind of what are our minimum requirements for that, and this is an example of most of what we came up with. So we need some robust data pipelines. They need to be, reusable, high quality. We need somewhere to store our models, somewhere to store our data. We need orchestration, because as soon as you start dealing with pipelines that involve machine learning, it becomes quite complex. There's a lot of dependencies. So orchestration is very important, and we needed monitoring, because we need to keep monitoring that our model is performing well over time. So this is kind of a very simplified diagram of what that looks like for us in practice. So what we're doing is obviously taking some source data. We're developing some feature engineering pipelines that get our data into the format that we need it for the modeling. We're then going to a training pipeline to actually train our model, producing a model itself. And then later, when we're ready, we're taking some more data, running it through the feature engineering pipeline, and then creating a prediction pipeline. Then what we're also doing is creating a presentation pipeline as well. So our prediction pipeline might only include the features that were originally used in the clustering plus the label for the cluster. But for our stakeholders to actually use that, they need some more information. That isn't enough information. So for example, if they want to email a customer, they'll also need an email address. So the presentation pipeline is where we enrich that data effectively with any other data points that we need. And then we're putting that into a target system. So on the next slide, just to illustrate some of the technology choices that we've selected so far in our platform. And so our source data at the moment for this particular use case happens to be in Amazon Redshift. We are using S3 to store our sort of intermediate data assets as we go. So every time, if we do the feature engineering pipeline, then we need to store down the data. For our data processing, our data is really large. So we are using Spark, and we're using that on Amazon EMRs. For our model, I said about starting simply, we use scikit-learn for that. And then we have our target system, which is Snowflake and then into Tableau, and that is basically a choice because that's where the stakeholders currently access their data. So we have our deployment platform and able to deploy the model. So the other aspect I mentioned was monitoring. So again, taking an MVP approach on monitoring, we looked at what do we need to do over time. And again, with unsupervised learning, it's a little bit harder to monitor because, again, with supervised learning, you might want to monitor something like the precision over time, but with unsupervised, it's a little bit more challenging. So what we did there was we just took the validation effectively that we did first time around, and then we're monitoring that over time. So we're monitoring things like, are the feature distributions changing? And also we're monitoring that PSR flag as well and how that's changing over time. We're also looking at, the other thing we're looking at is how customers are moving between the clusters, because that's quite important to us as well to understand. And then the other thing, of course, is that everything hinges on data. So we're also monitoring the quality of our data as well. So that kind of almost brings me to the end of the talk. Just to kind of recap on the project principles that we've got in place. That these are kind of shown on this slide. Obviously, the first one is taking the problems with clear action. So that's, to ensure that the model is useful and is used. The importance of having the stakeholders and the fact that we've identified 2 different stakeholders, which I think are really key to the success of the project, and that is the sponsors and the domain experts. The importance of starting out with something simple, not just trying to go for the most complex solution to begin with. And also, I think, for us in particular in this project, interpretability was extremely important. So that's another sort of reason to do something simple. The importance of having stakeholders involved in validation, particularly for unsupervised learning, was something that a big learning for us in this project. And then the importance of getting that model out into production as soon as possible before iterating, so you can get some feedback first. So that's everything for me. Before I go, I just want to say, if you are interested in helping Britain achieve net zero, we do have some open positions right now. We have an open data scientist position. We also have some other positions across the whole of the data and CRM platform, so we are hiring. So please, if you are interested, come and find me at some point today, or you can visit the website on this slide. But thank you so much for listening, and I'm happy to take questions if we've got time for those.
Thanks, Rebecca. That's clearly going to be a very relevant topic over the next few months. Has anybody got some questions at the back?
Hi.
How do you model data? Let's take an example. How do you model the possibility of Russian funds defaulting payments to the possibility of Russian flows being cut off to Europe and the UK?
Yes, so that's a great question. Unfortunately, it's probably not. Oh.
Let me just repeat.
Sorry,
So just for the benefit of everyone else, the question was about how you're modelling other areas of energy sector, so possibility of Russian defaults, possibility of Russian flows of energy being cut off.
Yeah, as I say, thank you. Great question. Unfortunately, I would say that I'm really not the best person to answer that question. It's really, really not my area of expertise. So I'm going to defect to essentially somebody else. So please feel free to come and see me afterwards, and I can give you an email address of somebody you can contact. But I don't want to even try to answer that question, but it's a really great question. Thank you.
The back over there.
Yes, so something recently when I've attended webinars that I've come across is surrounding this whole issue of data privacy, which I'm sure as you know is a big
Yes.
thing at
Yeah.
ETN.
Yes.
How do you address that issue? Because obviously you seem to use a lot of data, including very personal, potentially sensitive data. So how exactly do you address that?
Yeah.
So a question there about data privacy aspects, which obviously is relevant to the vulnerable population here.
Yeah. Again, great question. Security in our data is extremely important to us. Everything we do is security first. As I talked about, the platform that we're building right now, security is at the absolute heart of that. So we use masking for our data. So where if we don't need to use any personal identifiable information, we won't use it. We have all of our we have a big IT security team who give us the information about how we should secure our data and everything that we do. So any platform that we build, anytime we use data, bring data into a new environment, we have to go through the security team first, and they ensure that that data is kept safe and secure, and that's kind of how we do that. Thanks.
at the front.
Hello.
Yes. Did you show like other stakeholders that clustering algorithm output, and how do they sort of take it? How does that conversation go with like non-technical people? Do they understand? Do you have to explain? How did it sort of pan out?
So that's just a question about selling technical detail to non-technical stakeholders.
Yeah, no, yep, absolutely. So, to be honest, they were really engaged. Our stakeholders that we had in this particular project, although they were quite new to machine learning, they were very engaged with it, and we did show them everything. Actually, we obviously picked out certain aspects that were better for the validation to really get into in more detail with them, but we showed them everything. And actually, the clustering visualizations, they were really well received. They actually found them really interesting, and I think we were able to explain them in a way that was understandable for them. But in terms of actually building out the trust, we did find it was really important for us to bring out some of those other metrics that they already understood. So things like the PSR flag proportion, they work with that data every day, so they really, really understood that one.
They look really cool as well.
Oh yeah, no, they did. They're great. Actually, you're sitting next to the person that made those visualizations.
Okay, so we've got two here at the front.
Thanks for the talk. You mentioned in your team structure you've got a product lead and then someone's the lead data scientist there. With regards to you build it, you support it when it goes live, and I imagine that your team's going to be creating more products going forward. How are you going to envisage coping with a lot more products out there and supporting multiple products within that same team?
So basically a question about how you structure your teams to manage agile development and developing new products along the way.
Post-production support, yeah.
Thanks for the question. Yes, really good point. We are doing that. So we're starting to get to that point, I suppose. We haven't quite got there yet, but we are starting to get to that point where we have got quite a few models in production now, and we are having to manage those because, of course, we're monitoring them all the time. If something goes wrong, we need to potentially look into that. One way we're managing it is through automation. So we try and make sure everything is automated. That's why one of the reasons why we're building out this unified platform. So as much as possible, we can do things like automatic retraining models, automatically monitor and only sending alerts when there really is a problem. But what we're considering doing at the moment, on top of that, is to have a kind of a business as usual stream within the team. So what we would do is rotate potentially people in each of the product teams where they're on the business as usual this week, for example, and that their job is to fix any issues and that arise. So that's kind of what we haven't quite implemented it, but that's the thoughts that we have around doing that.
Okay, question there.
Thanks, Rebecca. Which clustering algorithms did you consider and which ones did you go for?
Which clustering algorithms considered and chosen?
Thank you for the question. So we looked at a few off the top of my head. We looked at dbScan was one of them, but actually quite early on we selected k-means, to be honest, because we actually used that first. It did actually work quite well. We did look at a couple of others and do some experimentation, but to be honest, k-means just worked quite well, so we ended up going with that. So we didn't look at lots and lots of them.
I have a question which is similar to the previous one, but are you going to consider more advanced models in the future? And how will you proceed with moving to these new models from the simple one?
Okay, so that's a question about whether there's a need to move to more advanced models and how you choose that and do that.
Yeah, thanks for the question. I think that is a question on the use case, the value that's coming out of that use case, whether we need to move to the more advanced models. So I think where we look on that is obviously everything we're doing is iterative. So even with this, so in some cases we're already using more advanced models in other projects. In this case, this one is quite early days, so we are at the very start. So the first sort of simple model. We will iterate on those where we see the value to do so. So it might be actually that model, when we get it into use and people are using it, that actually it just works okay, and there may be some value in iterating further and using something more complex, or we might actually find we think there's more scope here to continue to work on it. So that's the kind of trade-off we'll look at in terms of using something more complex. So I think the more complex algorithms you get, you're working with, the less interpretable the results are, and sometimes the harder it can be to do things like putting it into production and things like that for us. And but it isn't something we rule out. I mean, to be honest, we use whatever the best solution is, but we do take that iterative approach and only kind of continue to develop where it makes sense to us.
Okay, another question at the back there. Okay, so that was a question about how decision makers are using the model outputs and also whether you're evaluating whether they're making better decisions using the models.
Thanks for that question. So yes, we are working with the stakeholders right now to design some of the first experiments that they'll be doing. They're not quite ready yet, but we're in that process. Most likely it will involve reaching out to the customers in some way, so we haven't quite worked out exactly which route that will be, but it might be something like an email, text message, something like that. In terms of, and that would just be about reaching out to offer them some support, which is something we already do, but we obviously use different indicators at the moment. What we'll do in terms of understanding if that's working for us, I think, is to look at the results of whatever they do. So if they contact a customer in our group, and we'll probably look to do some experimentation, so some A/B testing with those segments, and then to understand if if we're getting the sort of responses, the response rates, I guess, to the campaigns, to understand how well the model is performing. So that is a really interesting consideration for once a model is being used is how you monitor if it's successful in the real world, because actually a model offline can look like it's great, but actually it might not solve the problem that well. So thank you.
Okay, one at the back.
What were the data challenges you faced, and what was the input for your cluster algorithm?
So there's a question about what your inputs were for the model.
Yeah, and plus data is the main key ingredient, right? So what was the challenges you faced?
Okay. So and what the challenges of using the data were.
Thanks for your question. So yeah, we have, I think like any business, we do have a lot of challenges around data. It's always a challenge. So we have, so one thing was getting access to the data. Fortunately, in this particular project, as I said, we tried to start simply, and we essentially tried to use data that we knew we had easily available that would help we thought could help to solve the problem first. So that kind of got over one of the barriers, because sometimes we do have trouble just even sourcing and getting that data to where we need to use it. What the challenge we have, though, for us is our data is, I'm sure this is probably the same for a lot of organisations, but our data is not very clean at source. So we have to do a lot of prep on that data first before we can actually use it. So that's probably our biggest challenge is the cleaning and the processing of the data and ensuring data quality as well, because that's the other thing is once it's in production, we have to make sure that level of quality we've got to initially continues and consistent. So I'd say, yeah, the data quality was probably the biggest challenge for us.
So I think we've got time for two more questions. There was one there.
Yeah, how do you create documentation that ensures that what you have done today is still understandable in 5 years' time?
Okay. How do you document so that people in the future know what you've done?
Yeah, thank you for that question as well. Yes, so we do, documentation is inherent in our process. So we use Confluence, so if anyone else uses that as well here, for our documentation, that's where we store everything. Every single product team has a Confluence area. Every time we have a new product, we create a new product area in our Confluence, and we make sure we document everything there. We also, obviously, we version control our code, so our code is all documented on, in GitHub. We also use Sphinx documentation for our code as well as an additional documentation, and we use lots of tools actually as well. We have Miro where we do kind of our workings, and we keep that. So yeah, documentation is hugely important to us. So yeah, that's how we do that.
Okay, but another question, that gentleman there. Okay, sorry.
So you mentioned your ML platform. I was just wondering, how you came to the decision of building your own ML platform rather than going for third-party or even open source.
So challenges of building your own platform.
Yes, thank you for that question. So yeah, so one of the challenges for us is our data, as I've said earlier on. So our data is coming from, at the moment, it's coming from some legacy systems, and it is very, very messy. And so we have a particular need for very, very large-scale processing, but not just that, but very, very bespoke processing from these tables and files that we're getting in. What we found with using, at the moment, using kind of something like Spark on EMR just to do that processing is that we've been able to build up our own code base around the data that we know we use a lot. So we can build up our own bespoke sort of code base within that. We just have a lot of flexibility. So we have a lot of flexibility with the tooling. So in terms of machine learning, we can use potentially anything because we can build on top of that. Now, we haven't ruled out third parties actually, and we are currently looking at whether there's other things that we could bring into our stack. So we've got a basic stack at the moment. it doesn't do everything, and it's not fully automated. So we are looking at other tools out there that could help. So we may probably land on a hybrid approach, I think, in the end.
I know there's some more people who've got other questions. Unfortunately, we've got to get people out and in for the next talk. I'm sure Rebecca will be delighted to talk to anyone throughout the day. But in the meantime, can we thank Rebecca again for an excellent talk?